Good morning, friends and dear students. I feel immense pleasure to be here again for my course, Engineering Thermodynamics. I am in the last phase of Engineering Thermodynamics. This is my last module, module 5. In that module, I have already covered the heat transfer, heat exchangers. This is my last topic of this. In this, I will be discussing about compressors. You might have seen that in our power cycle, we have different types of power cycles like Otto cycle, diesel cycle, dual cycle, Brayton cycle, Bell-Coleman cycle, or Carnot cycle, Rankine cycle. All this we have already learned. And in every cycle, you have seen that there is a process which is called the compression process. Without compression, we cannot work. We need a compression and we need a expansion devices. So how the compression will be done? We have seen the mathematical expression for reversible adiabatic compression, that but what is this compressor? How these compressors are working? Where these compressors are used? You might have seen for charging your vehicle near the petrol pump, you will see that one point is there. There they are putting the air or the nitrogen in the vehicle tire and you are inflating your tire. This air, the high pressure air is obtained from the compressor. Compressors are different types, different ways. It may be reciprocating, it may be the rotary, or it may be the centrifugal flow, it may be the axial flow. Different types of compressors are there. In this lecture, I am going to discuss about concept of the compressor in today's class, because any work producing device or any work absorbing device like engines, gas turbine engines, power plants, everywhere we need some compressor. So without compressor we cannot work. So we should know how many types of compressors are there and how they are working. So in this class I am going to discuss about basic concept of compressor. So in this we will see that the introduction to compressor, that is the first topic. Types of compressor: positive displacement compressor, reciprocating compressor, rotary screw compressor, rotary vane compressor. These are the different types of compressor which having specific uses. They can be used for a certain area, they are more effective, but they cannot be used everywhere because they have some limitations, they have some advantages and some disadvantages. We cannot use one type of compressor everywhere. Okay, so as per that, we have made some different types of compressor. They are devised, they are developed for the different purposes. So I will go for the introduction to the compressor, and in this you can see that a compressor is a mechanical device that increases the pressure of a gas by reducing its volume. So we know that pressure and the volume both are inversely proportional. If you want to increase the pressure, we have to decrease the volume. So what we do is we take some amount of, we will suck some amount of gas and then we will compress it. So the compression will take place. During the compression process, pressure and the temperature both are increased. So an air compressor is a specific type of gas compressor. Compressors are similar to the pump. Both increases the pressure on a fluid, on both can transport the fluid through a pipe. So pump also can transport the fluid and compressor also can transport the fluid. But there are some basic differences. The main distinction is that the focus of the compressor is to change the density or volume of the fluid. So in this compressor, we try to change the volume. If you change the volume, the density of the fluid will be changed. But for the pump, for the liquid, we cannot do that because it is incompressible. Gases are the compressible. It is mostly only achievable on gases. So we can use compressor for the gases like air or other gases. Gases are compressible while liquids are relatively incompressible. So compressors are rarely used for the liquids. So we don't use compressor for the liquid transportation or for the pressurizing of the liquid. Only we use the pumps like water. If you want to use the water, you can only use the pump, not the compressor. The main action of a pump is to pressurize and transport liquid. So the main function of the pump is to pressurize and transport the liquid. Any compressor can be changed, that is, the fluid is compressed several times in steps or stages to increase discharge pressure. So every compressors will have number of stages because as per the pressure requirement, as per the level of the pressure, we need the different stages, different step. It may be the 10 stages, 15 stages or 17 stages as per the requirement of the pressure that we have to change. The stages increase or decrease the changes. Often the second stage is physically smaller than the primary stage. So the first stage will be the bigger, then the second stage will be slightly smaller. As you go more and more stages, the size of the stages will be reduced because the volume is getting decrease. And to accommodate the already compressed gas without reducing its pressure. So we have to decrease the size as and when we increase the stages. Each stage further compresses the gas and increases its pressure and also temperature. So now I will discuss about the types of the compressor. So here we have a chart. In this I have taken from the Wikipedia of the compressor. So here we have the compressor types. We can divide in the two groups. One is the positive displacement and another is the dynamic. In the positive displacement, we will have a reciprocating compressor and the rotary compressor. In the reciprocating, we will have the diaphragm type, double acting type and the single acting type. In the rotary, we have the lobe type, screw type, liquid ring type, scroll type and vane type. Out of this, some we will be studying, not all. For the dynamic, which normally we use in turbo engines, they are the dynamic. We will have the centrifugal compressor and axial flow compressor. So slowly I will go through and a very brief idea I will be giving for each and every one. So compressor, positive displacement and the dynamic. In positive we have the reciprocating, like piston will move up forth and backward. It is called the reciprocating. It may be the diaphragm type, double acting or the single acting. If we show the rotary type, we will have some rotation like screw, lobe, liquid ring, scroll, vane. These are the few types which are expressed in this diagram. I will discuss the one side. It is called the positive displacement compressor. A positive displacement compressor is a system that compresses the air by the displacement of a mechanical linkage, reducing the volume. So positive displacement compressor is a system that compresses the air. So it is sucking first and it is compressing like this. So this much volume has come down to this much of a mechanical linkage, reducing the volume. So if you see the piston arrangement, this is the inlet valve and this is the exhaust valve. This is the piston. Here is the crankshaft here. So this will move. So it will initially it will move. This inlet, this is the outlet. So inlet valve will open. So it will move from here to here. After it is reached here, then it will compress it again. So this much volume has become this much. So here you will have the compressed air. Compressed air. So this outlet valve will open and it will go to the required place. A compressed air will go. It may be single acting. It is here I am showing the single acting. Sometimes it is a double acting. Both side it will act. Means it will, when it is moving here, it will compress. When it is moving this side also, it will compress. It is called the double acting. So a positive displacement compressor is a system that compresses the air by displacement of a mechanical linkage. So these are the mechanical linkages here, and they are displacing and they are reducing the volume. Since the reduction in volume due to the piston in thermodynamics is considered as a positive displacement. So this piston is moving, so it is called the positive displacement. A positive displacement compressor is one that operates by drawing in a discrete volume of gas from its inlet, then forcing that gas to exit via the compressor outlet. So here it is the outlet, this is the inlet. So just now I have explained, this same thing is mentioned here. The increase in the pressure of the gas is due at least in part to the compressor pumping it at a mass flow rate which cannot pass through the outlet at the lower pressure and density of the inlet. So the increase in the pressure of the gas is due at least in part to the compressor pumping it at a mass flow rate which cannot pass through the outlet at the lower pressure and density of the inlet. So this is about the positive displacement compressor. Now I will discuss about the reciprocating compressor. Reciprocating compressors use piston driven by a crankshaft that can be either stationary or portable, can be single or the multi-stage, and can be driven by electric motor or internal combustion engine. So it can be operated in the different ways. Small reciprocating compressors from 5 to 30 horsepower are commonly seen in automobile application and are typically for intermittent duty. So this reciprocating will do the intermittent duties. Larger reciprocating compressors well over 1000 horsepower are commonly found in large industrial and petroleum application. So smalls are used for our bus, our truck charging of these things are used. Discharge pressure can range from low pressure to very high pressure, 18,000 psi or 180 megapascal. We can develop this much pressure. In certain applications such as air compression, multi-stage double acting compressors are said to be the most efficient compressor available and are typically larger and more costly than comparable rotary units. So these reciprocating compressors are very effective. It can be a very high compression ratio, multi-staging or double staging compressors we can do. They are most efficient and also they are very costly and the size is more comparing to the rotary units. Another type of reciprocating compressor usually employed in automobile cabin air conditioning system is the swash plate or wobble plate compressor, which uses piston moved by a swash plate mounted on a shaft. So this is a swash plate is there like this, and here is it will rotate here and it will go like this. So your compression will take place. It is called the sway plate. It is a tilted plate. Sway plate is a tilted plate, and that will press the piston and the cylinder, and in that way the compression will take place. So you can see here when this diagram is here, a small stationary high pressure breathing air compressor for filling scuba cylinder. So a small reciprocating compressor is here. This is the motor, and here these are the filters and other things, and here is this reciprocating pumps are here, and they are making the system and compressing. Here we have the dryer and other things. A high pressure reciprocating compressor is here, and this is the compressor from Bellis and Marcom used in the bottling industries. So this is just a diagram to show that like this your compressors, reciprocating compressors will be visible. You might have seen a small compressor for the painting they use. Those are the very small horsepower compressors. They are used for different purposes. Now I will discuss about the rotary screw compressors. These are usually used for continuous operation in commercial and industrial application, and may be either stationary or portable. Their application can be from 3 horsepower to over 1.2 horsepower, 1200 horsepower, and from low pressure to moderate high pressure. This is the use for application can be from 3 horsepower to over 1200 horsepower, and from low pressure to moderately high pressure we can use this type of compressor. The classification of rotary screw compressors vary based on the stages, cooling methods, and drive types among others. So here different types of screw compressors are there, and their stages, number of stages, cooling methods we can classify as per that. Rotary screw compressors are commercially produced in oil flooded, water flooded, and dry type. So they are the 3 types. One is the oil flooded, means inside oil is there, inside water is there, and some one are the dry where we don't put anything. The efficiency of the rotary compressor depends on the air dryer, and the selection of air dryer is always 1.5 times volumetric delivery of the compressor. So images of the screw compressor we have here. So this you can see here, we have the rotary timing gears are here. We have the bearings here, different bearings are here. Here we have the seals here, different seals are there, and here is the water jacket. These screws are moving opposite direction. One set is this, and they will move like this, another move will like this, and air will enter and it will be compressed. These screws are making these things to compress, and they are rotated by the help of external motor. Here oil free rotate set. So here no oil, only free air is here, and it is operated. Here we have the water jacket for the cooling. So your whole system has to be cooled. This is a full set of screw compressor. Here we have all types of, here is the motor, is a hot separated oil here, compressed gas outlet, compressed gas here. Here we have oil separator, gas oil separator. Here we have the micro oil filter, and here we have the oil cooler. So here we are putting the oil, and in this way we are getting the high compressed system. Now we will talk about the rotary vane compressor, another type of compressor. Rotary vane compressors consist of a rotor with a number of blades inserted in a radical slots in the rotor. So it is a rotary, it is rotating, and in the rotor we have the number of blades, and these blades, it is a rotor, and here number of blades are here. These blades are rotating. The rotor is mounted offset in a larger housing that is either circular or a more complex shape. So these rotors are not at the center, but they are made some offset and they are fixed inside a circular or a more complex shape area. As the rotor turns, the blade side in and out of the slot, keeping contact with the outer wall of the housing. So as the rotor turns, the blades will go up and down and it will cover one side more area, another side it is a less area. Okay, just you can see here. This is the center and these are the blades. They are moving up and down. So if you move like this, this volume is more. As they are compressing from here to here, the volume is reduced and it is going outlet. So in this way, compressors are taking place. Here is the inlet. From here, air is entering here. Volume is increased, but this will be keep on trapping. And this much volume will be reducing to this much, and the volume reduction will increase the pressure. And here the high pressure you will get. Here it is a low pressure, so it is shown by the red. As the rotor turns, blades slide in and out, and the slot keeping contact with the outer wall of the housing. This will be always touching this wall. It will be entering, so it is flexible. It can go inside and outside, and another blade will again start the next axle. Thus, a series of increasing and the decreasing volumes is created by the rotating blades. Rotary vane compressors are with piston compressor, one of the oldest compressor technology. So it is very old technology. With suitable port connections, the devices may be either a compressor or a vacuum pump. It can be as a compressor or we can use as a vacuum pump. They can be either stationary or the portable, can be single or the multi-stage, and can be driven by electric motors or internal combustion engine. Anything you can use, if you have the electricity, use the electricity to rotate this pump, and if you don't have, you can use a piston engine and you can rotate this pump. So these are the references which I have taken: Yunus Senegal, Michael Abels, Thermodynamics and Engineering Approach, Tata McGraw Hills, and Hope. Any questions you can ask to my email ydwedi@gmail.com. This is my email. You are welcome to ask any questions. Please do like and subscribe my channel. Thank you very much for joining this class. Hope you will retune for my next lecture. And the next lecture will be some numericals on heat transfer. 2 more lectures I will be doing, and then I will be ending this lectures. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.